Hi, what I have here on the workbench today is a ZOYI-1000R multimeter and insulation tester. I actually needed one of these as I currently don't have an insulation tester in my lab, so I'm pretty excited to get one of these as it will for sure come in handy in future videos. Thanks Zotek for providing me with this unit to review. As usual, I will leave a product link in the video description below for those who are interested in getting one after watching this video. This meter is currently priced under $50 at the time of making this video, so it is relatively inexpensive. Of course, we'll need to see how well it works. Size-wise, to put things into perspective, it is actually slightly chunkier than the standard handheld multimeter like the Unity UT61E Plus I have here. These two meters are pretty much the same dimensions in terms of length and width, but the ZOYI-1000R is noticeably thicker and weighs quite a bit more. And that is quite understandable as it has built-in circuitry for generating the high voltages required for insulation testing. This meter can output from 50 volts up to 1000 volts for insulation testing, and the maximum insulation resistance can be measured is spec'd at 20 gigohms. If you look at the dial switch here, you will notice that it essentially combines two meters into one device. The selections on the right-hand side here are for the multimeter section. Noticeably, the multimeter does not have current measurement mode. The selections to the left are for the insulation testing. You probably also noticed that the off position is actually in the middle here. Now, if you ask me, my preference would be to have two off positions, one on either end, so you don't have to look at the dial when turning off the meter. All you need to do is just turn it all the way to one side or the other side, and then the meter would be off, instead of having to look at the dial to ensure that the meter had been turned off. Anyway, there's nothing wrong with this design, it's just my slightly different preference. Now, this meter is powered by three 14500 rechargeable lithium-ion batteries, and they are provided. I'll show you when we do the teardown a little bit later, as I had already put them in. Having rechargeable batteries is actually quite standard, but one thing interesting that there's no way for you to charge the batteries while they're installed, and you can see that there is no USB port on this meter itself, so that you cannot charge it when the batteries are in the meter. In fact, Zotek provided a separate charger for you to charge up the batteries. This means that you'll have to take the batteries out when they need to be recharged. I think I know the reason why they didn't include the charging circuitry on board. We'll discuss that a little bit later during our teardown. But you can see that the charger provided here is a rather generic one. It can accommodate different sizes of batteries, but there's nothing fancy about it. Like many of the Zotek instruments I reviewed recently, they all come in this soft pouch, very generic, and inside you have the user manual, some leads, and of course you have these alligator clips for you to clip on for insulation testing. And of course you have a thermocouple here because this meter can measure temperature. Actually, let's take a look at the supplied probes here. Open it up. Now I think these are going to be very generic here. So the probes feel pretty soft, and there's nothing fancy about them. Let's take a look at the tips. Yeah, they're just your standard ones. They are not gold plated, but for all intents and purposes, they should be just fine. Anyway, I think what I'm going to do is I'm going to test out the insulation tester first, as that's what we're most interested in. And then, of course, we'll take a look at the multimeter briefly. And before I power it on, let's actually remove the screen protector. As you can see, we actually have a bubble here. And let's remove it. First, we're going to take a look at the output voltages when in insulation testing mode. As we have different voltages you can select from, I want to see how accurate the output voltages are. And for that, let's just use my Unity UT61E Plus to do the measurement here. So I'm going to hook it up. By the way, we have two sets of sockets. These are for the multimeter, and this set is for the insulation tester. So let's plug it in. And let's turn it on. Don't know how well it shows up on camera, but the display is actually pretty sharp on the ZT-1000R. Anyway, now I set the output voltage to 50 volts, and let's actually turn it on and see what the voltage measurement is. Now, before I actually turn it on, you can see that the output is at minus 0.4 volts. There's some residual there, but I don't think that matters. So let's turn it on. So for that, I'm going to, let's say, do 15 seconds, and let's start the testing. Yeah, you can see that for the 50 volts range, we are outputting roughly 54 volts. So that is actually roughly 9% difference, and it shouldn't really matter for the output voltage. Of course, the test is 15 seconds, so now the output has been turned off. And of course, on the insulation tester, currently you are reading 10 megohms. That's because that's the input impedance of the meter here. Anyway, you probably notice that the high voltage output is actually of negative polarity. My understanding is that this is actually quite standard for insulation testers, as one of the key testing scenarios is to test a cable insulation between the core and outer sheath. When moisture is present due to electroendosmosis, if negative voltage is applied to the conductor core, the moisture would be drawn towards the core versus being repelled if the polarity is swapped. So the measured insulation resistance with negative polarity would potentially be lower than the other way around. So this helps identify issues that may not be apparent otherwise. All right, let's continue verifying the voltage output from the other ranges here. So let's do 100 volts, and let's do select, test. You can see we're outputting 102 volts, no problem. Let's do 250 volts. $255, no problem. Let's do 500. And 510, that's pretty much right in the ballpark. Okay, now let's move on to 1000. And of course, is out of range on this Unity UT61E Plus. You can hear the beep. So let's actually turn it off. Now, for the 1000 volts range, actually most of the meters I have in my possession can't test that because it's over range. Anyway, so the only meter I can actually test that voltage is the MDS9208 I have here. So let's actually give that a try. So let's start. And of course, it is still beeping, but at least it measured its 1022 volts. Of course, the numbers displayed on the insulation tester here is the input impedance of the meter here. Now, when I reviewed this MDS9208, I actually didn't test the input impedance, but you can see here it's not your standard 10 megohms. The input impedance is actually only at 5 megohms for this meter. Before moving on to insulation testing, I actually wanted to figure out the surface resistance of this ESD mat, as we are able to measure up to 20 gigohms with this insulation tester, so we should be able to measure the surface resistance. As my guess is, it probably would be in the gigohm range within a few centimeters distance. So let's give that a try. And for that, I'm going to, let's see, 15 seconds, that should be fine. All right, I'm just going to hold down the probes. Of course, this is not very scientific, but it should get the ballpark. And you can see here, we're measuring roughly 10 gigohms. So that's a G, not a megohm. So the surface resistance is actually quite high for this ESD mat. Next, let's test out the insulation resistance of a couple of desoldering irons that I recently reviewed. If you recall, I couldn't properly test the insulation resistance because I didn't have an insulation tester at the time of the reviews. But now we should be able to verify that. So this is the one that I recently reviewed. And let's see what the insulation resistance is like. And as I mentioned in my previous reviews of these desoldering irons, because they use 2-prong plugs and there's no dedicated ground, so you could get into a bad situation if somehow the live wire touches the case. And it would be dangerous to both you and the equipment that is being repaired. So that's why insulation resistance testing is critical for these kind of devices. Anyway, the supplied alligator clips comes in handy here. So let's do one of the prongs. And let's choose the top here. So what I'm going to do is I'm just going to do 15 seconds. By the way, you can select different testing time here. For example, 15 seconds, 1 minute, 2 minutes, so on and so forth. So let's do 15 seconds as we don't have a lot of time on this video here. So let's do test. So you can see after 15 seconds, we are not able to measure any meaningful resistance, which means that the insulation resistance is likely greater than 20 gigohms. And let's try the other prong. And again, you can see that we are not seeing any measurable resistance, which means the insulation resistance is also higher than 20 gigohms on the other end. Now let's try a different iron here. Again, no issues. Let's try the other side. So as you can see, for both of these irons, we were not able to measure the insulation resistance. So this means that the insulation resistance under 1000 volts for these meters, under the conditions that we are using here, is at least greater than 20 gigohms. Of course, that timed measurement is just one way of measuring the insulation resistance. And we have a couple other features I'd like to show you here. So you've noticed we have this button, rel, pi, and /dar. So we can actually use this button to cycle through different measurement mode. And you notice that right now we're in this DAR mode. What does that mean? DAR means dielectric absorption ratio. It is calculated by measuring the insulation resistance twice, typically over 1 minute. And the ratio is obtained by dividing the latter measured resistance over the first resistance measured. A good DAR value would be over 1, and I think some sources mention that it should be over 1.4. And a ratio less than 1 would indicate that there's a problem with the insulation resistance, because the insulation resistance is dropping over time. But insulation testing is not really in my area of expertise, so do leave a comment if I mention something incorrectly. So while we still have this desoldering iron hooked up, let's actually take a look at the DAR measurement of this iron. And we just finished testing. You can see here we got a 0.8. So that actually means there's probably some degradation once we apply the high voltage over time. So that definitely is not ideal for this desoldering iron. Let me actually swap it to the other prong and test it again. So this time, actually, let's change the polarity as well, just to mix things up a little bit. And let's see here. Of course, because it's going to take a minute, I'm not going to wait here. I will show you the results. And you can see we're done, and the result is 1.00. So basically, it means that the resistance measured at the end of 1 minute is the same as the one measured at the beginning of the testing. And that means it's actually okay. I don't know if this is actually accurate. And you saw that earlier, we were not able to measure the insulation resistance, so I'm not sure how much we should be reading into the actual value here. Either way, I think the insulation property of this desoldering iron is actually fine. So let's actually try it on a different soldering iron. Now let's try measuring the DAR value of the other desoldering iron. Again, the result is pretty much what I expected. Because the insulation resistance is greater than 20 gigohms, I don't think we're able to get any meaningful readings. So I think the meter assumes when you can't measure the resistance, the before and after results are the same. And that's why we get this 1.0 for the DAR reading. And also, as I mentioned earlier, you can also cycle it through, and you can measure, for example, besides DAR, you can also measure PI. And the PI measurement is essentially for polarization index. This actually measures pretty much the same thing as the DAR, at least according to my understanding, except that the test is done at a much longer interval, usually with resistance measured at 1 minute and 10-minute intervals. And a good ratio for the polarization index is over 2. Again, if you get a ratio of less than 1, it means that there is a problem with the insulation, as the insulation property of the material clearly deteriorated over time. Alright, now let's briefly take a look at the multimeter function. So currently I'm in DC voltage measurement mode, and I'm going to put in a voltage from my voltage standard, the MV216A. Because the meter has a resolution of 0.1 millivolt, let me actually test whether or not that's accurate. So I'm going to put in 0.1 millivolt at a time, 0.1, 0.2, yeah, we're registering that, 0.3. So you can see that we are able to register 0.1 millivolt. That's good. 0.4, 5, 6. Yeah, no problem. So let's do 1 millivolt at a time. 1, 2, 3, 4. No issues. Actually, it's quite accurate. 5, 6, 7, 8, 9, and 10. Very good. Now I'm jumping straight to volt measurement. Currently it's 1 volt, 2, 3, 4, no problem, 5, 6, 7, 8, 9, 10. And I forgot to mention the multimeter actually has 20,000 counts. So you probably noticed that when we increased from 1 volt to 2 volts, we actually lost a digit. So here is 1 volt and 2 volts. Because we're still under 2 volts here, technically, so we're still seeing a resolution of 0.1 millivolt at time being. But if I increase it to, let's say, 2.1 volt, so now you can see we dropped a digit. And here is the AC range measuring the mains voltage. You can see that the update rate is not that fast. It's about 2 times per second, definitely a lot slower than in the DC measurement mode. So now let's actually change it to frequency measurement. And you can see that we're able to measure the frequency with no problem. And now let's take a look at the resistance measurement. And by the way, here are the specifications of the multimeter. You can see that the accuracy is actually pretty good. And we did see that earlier. It was pretty much spot on for DC measurement. And you can see it's actually 0.05% plus 3 counts. That is actually pretty accurate. And in resistance mode, you can see the maximum resistance we can measure is 20 megohms, which is pretty much standard for multimeters. Now, of course, the insulation tester can measure up to 20 gigohms, and that's because the insulation testing is using separate circuitry. Anyway, let's take a look at the resistance. So right now I have switched to resistance mode, and let's take a look at the speed here. Yeah, it's definitely on the slow side, you can see here. So let me try route out the readings here. It's already pretty low, so let's actually keep it as is. And the first resistor we're going to measure is a 100 ohm precision resistor. This one is rated at 0.1%. So let's take a look here. And give or take, I think the reading is pretty good. The next one we're going to measure is this 1.25K 1% tolerance resistor. And you can see that the reading is pretty accurate. All right, so let's jump directly to a 1 mega resistor. The resistance measurement speed is actually pretty fast. You can see that here. It's just when we're shorting the leads, I think it took a few seconds. But yeah, the speed is no problem. Now we're in capacitance measurement mode. Let's actually take a look at a small capacitor. The one I have here is a 33 picofarads capacitor. Let's give it a go. You can see that no problem. We're able to measure the capacitor. Of course, the reading is a bit off, but nevertheless, we're able to register a reading here. So let's actually take a look at another small capacitor. And this one we're going to look at is a 22 picofarads. So we'll see in relative terms whether or not we're able to discern that. Yeah, we are. And you can see we're measuring 33, and the other one we're measuring roughly 50. So clearly we are able to measure small capacitors. Of course, the accuracy is not going to be that great because we have these long leads. And let's try a 1 microfarad capacitor. Yeah, no issues. And now let's jump directly to a large capacitor. And this one is a 15,000 microfarads capacitor. And let's take a look. Of course, I'm expecting it to take some time. And indeed, it is taking quite a bit of time. You should be able to measure that though. Wow. Yeah, eventually you can see that it is showing 13 millifarads, and that is right in the ballpark, but it did take quite a bit of time. And let's move on to diode measurement. For that, I'm going to measure a white LED directly. I'm going to skip the silicon diode. Yeah, you can see that we're able to light it up at 2.6 volts, not a problem. But of course, we don't get a beep that indicates it's a good PN junction. Let's short it. And on some meters, you'll hear a continuous beep when the PN junction is shorted, but in this meter, obviously, you don't get that feature. Now let's try out the continuity test. It's latched. and it's reasonably fast. And I think the leads, because they are not gold plated, they don't make good contacts. But once they do, you can see that we don't have any issues. And you can use the supplied thermocouple to measure temperature. Nothing fancy. Here is the temperature of the lab. You can see that we do have the dual display showing you both Fahrenheit and Celsius. Anyway, time for us to open it up. I'm expecting to see some high voltage circuitry inside. And I'm measuring the current consumption at the moment. Right now, I have the high voltage turned on. It's outputting 1000 volts. You can see that we're actually only enjoying 26 milliamps. So that's actually quite good. And the battery will definitely last for a long time. I think I forgot to show you, this meter actually has a backlight. And from this angle, it doesn't look that great, but the backlight is actually pretty nice. Now, when the backlight is on, you can see we're only enjoying 17 milliamps. Of course, the backlight actually is a little bit different on this meter. You can see that when the backlight is turned on, let me show you here, it actually has this flashlight at the front. So that's pretty much the power consumption. If I turn the backlight off, the multimeter is only enjoying about 4 or 5 milliamps, as you can see here. So here's a battery compartment. You can see that we essentially have 3 of these 14500s in series, and each one has 500 milliamp hour capacity. So given the modest current draw, the batteries inside can last a long time without having to be recharged. And the reason they need to be taken out to be recharged is because these batteries are in series, forming the 12 volts. You can see here we only have 2 connectors. Of course, you can always design an in-circuit charging, but it will be more complicated because now we're talking about 3 cells instead of a single cell, and now you have to include the balancing circuitry as well. So I guess that Zotac, probably after weighing the pros and cons, decided not to include the charging circuitry as it will make the cost higher. From the PCB here, you can see that this is the initial design, version 1.0, and it was released back in February 2025, so not too long ago. Overall, you can see the design and the build quality is actually excellent. We don't see any botched wires anywhere on the board. The chip up here, that would be our DMM chip. Of course, we don't have any markings on it, so I don't know which chip they're using. And the chip up here is marked as OP021. Now, I don't think that's an op-amp, even though the marking starts with OP. I think that perhaps is a microcontroller. And a section of the circuitry here obviously is dedicated to the high voltage generation. And you can see here is a pulse transformer. And interestingly, the high voltage is controlled by this PWM controller, TL494. And here we can see these 2 resistor strings in series. These are for handling the high voltage. By the look of it, we only have this single PDC for protection on the multimeter side. Remember, these 2 are actually the multimeter inputs. These are actually for the insulation testing. And just for completeness, I actually removed the board. And I wasn't expecting anything on this side, and indeed there's nothing on the reverse side of the board. And that pretty much concludes today's video. The ZT-1000R is a pretty basic insulation tester. Besides different voltages and a couple of standard measurements, there are no other fancy features. But considering it's a rather inexpensive insulation tester, and it also has your basic DMM functionality built in, it is certainly worth getting, in my opinion. Anyway, I hope you enjoyed this video. If you liked it, please remember to give it a big thumbs up, and don't forget to subscribe to the channel for more videos like this in the future. Your participation makes videos like this possible. Thanks for watching, and I will see you next time.